Hello, I'm Rebecca the Maths Lady and welcome to this first video in the series on teaching number to children aged 9 to 11. And this video is all about teaching factors and prime numbers. In this video, I'm going to explain how we teach children about factors, factor pairs, composite numbers and prime numbers, as well as common factors. I'll show you how to teach this topic using arrays and a sieve of Eratosthenes and factor bugs, and I'll explain about how this topic fits into the learning journey of children at this stage. So if you already know all this and you don't need this video, here's your link to your next video, which is about triangular, square and cube numbers. This topic assumes that children have already done a lot of work on their multiplication tables, which we covered in series 2 on number for 7 to 9-year-olds. So if you think you need to review that, then here's a link to the key video on the foundations of multiplication. Right, let's get started. All mathematics can be taught with pictures, and that's the most powerful way to teach it because it links all the different ways that people think about their maths. And the best way to teach the topic of factors and prime numbers is to get children to think about rectangles. So when I'm working with children, if I have some unit blocks handy, I always work with them because they're so tactile and lovely to work with and to arrange into rectangles. But if I haven't, I'll either make some paper squares to move around, or I'll just work with drawing on squared paper. So if I'm asking a child to find the factors of 12, I don't use that language at first. I give them 12 squares and ask them to arrange them as a rectangle. And there's several ways of doing this. Quite a common way would be to imagine a rectangle like this. Now this rectangle shows you that 2 times 6 is 12, or 6 times 2 is 12, depending on which way you look at it. And you can start to introduce the vocabulary that factors are the side lengths of rectangles that make up a number. So 2 is a factor of 12 and 6 is a factor of 12. And 2 and 6 are a factor pair because they make a rectangle with 12 squares. Now you're wrapping that language around what the child is doing, but the essence of the challenge is that the children need to build rectangles with 12 squares. So let's see if it's possible to make another one. Give them that challenge. Can they make a different shaped rectangle with 12 squares? Well, here's one. And this shows that 3 is a factor of 12 and 4 is a factor of 12. And 3 and 4 are a factor pair for 12. Are there any more rectangles? The other one isn't so obvious, but of course there is a long skinny rectangle like this. And this rectangle shows you that 1 is a factor of 12 and 12 is a factor of 12. And 1 and 12 are a factor pair for 12. And at this stage you can have loads of fun playing around with this, building rectangles with different numbers of squares. If you haven't got squares, print off some squared paper or draw some, and you can try to draw the rectangles on here. It's the same idea. Really do allow plenty of time for this exploration because there are so many things that children come to see. You also want to wrap in the idea that a factor is a number that the big number will divide by exactly with no remainder. All this maths fits together beautifully. And as children play around with this, they will also sometimes come across numbers that they can organise into squares. So if you're dealing with a number like 16, you will get a long skinny rectangle. I can't fit on this board. It's 1 by 16, so 1 and 16 are factors and 1 and 16 are a factor pair. You'll also get a rectangle that's 2 squares high and 8 squares long, or the other way round, and that shows you that 2 and 8 are factors and 2 and 8 are a factor pair. But you will also get a square that's 4 by 4, and that shows you that 4 is a factor, but there's only 4 because both sides are the same length. And as you explore this, you will discover prime numbers. Prime numbers only make long, skinny rectangles. They won't make a rectangle of any other shape. But every number 2 and above will make a long, skinny rectangle. So every number has a factor pair of 1 and itself. But prime numbers only have that factor pair. They only make long, skinny rectangles. Now, lots of schools love to create factor bugs, and children just adore them, and I think they're wonderful too. They consolidate that visual image of factors and composite numbers and squares in such a visual way. So for our factor bugs, we just draw a little bug. There it is. Let's give it some antennae. We put our number of the day, the number that we're working on and finding factors for, in the factor bug. Let's take 48. And every factor pair is going to become a pair of legs for your factor bug. And if you've got a single factor, because it's a square number, then you're going to get a tail with that factor on. So for 48, as with every number, we're going to get 1 and the number itself. And we think about 2. Does that give us a factor pair? Well, it does. It goes with 24. 3, does 3 go into 48? It's a lot of work there. It turns out that it does. 3 goes with 16. Does 4 go into 48? Yes, it does again. 4 and 12. 5, does 5 go into 48? No, it doesn't, because that number does not divide by 5. You get a remainder. What about 6? Does 6 go into 48? Can you see how much work is going on here? Well, it turns out 6 does. 6 8s are 48. Loads of great practice. 48 does not divide by 7, because 7 7s are 49, so it's not going to work. And then once we get past a number that's already on this side, we know that we're done, because we're going back the other way and just turning our rectangles round now. So I just can't recommend this highly enough as a warm-up for any math session, and as great practice to all those skills we've worked on between the ages of 7 and 9. Factor bug of the day. If you've got a prime number, it's only going to have 2 legs, but there's still lots of work in checking that you've got a prime number. And if it's a square number, which we're really covering properly in the next video, then it will have a tail for the single factor. At some stage, you should also do a sieve of Eratosthenes with your child. And that's just an exercise in finding prime numbers by eliminating the numbers that are not prime from a number square. So I'm going to leave one just for now. It's not prime. I'm going to come back to that in a minute, but I'll cross it out. So we start by thinking about the 2 times table. Now 2 is a prime number. The first number in a times table often is, but then everything else in the 2 times table is not prime because it divides by 2, or it'll make a rectangle that's 2 squares high. So we can get rid of everything in the 2 times table. Then we can think about the 3 times table. If I just change colour, 3 is a prime number. But now we can cross out everything that's in the 3 times table. So that's 9, 6 is already gone, 15, 21, and so on. Then you continue with your 4 times table and you discover that that's completely gone already because every number in the 4 times table is also in the 2 times table, and we've dealt with that. Then we come to 5. 5 is prime. Cross out the number in the 5 times table, so this whole column's going to go. And you work like that up to 10 times 10, because once we get past 10, we're coming up the other side of the beetle. We're done. And your prime numbers are the ones that you are left with at the end of that process. And it's a great exercise to work through because the child or children you'll be working with will be seeing all sorts of patterns in number that are really real and really important, and it's giving them a chance to focus on those. And the more you can link this exercise back to your rectangles and your bugs so it all fits together in the mind of the child you're working with, the better. So let's talk about 1 not being a prime number. There's a couple of ways of getting that. One which many teachers use, is to say that it's arbitrary. We had to come up with a definition of a prime number, and we came up with the definition that a prime number has exactly 2 factors. 1 only has 1 factor, therefore it's not prime. That works to an extent. It's like rounding. 5 could have gone up or it could have gone down, but we had to make a decision. 1 could have been a prime number, 1 could not have been a prime number. We had to make a decision. So it is logical, but there's a bit more in it, in that any number can be made as a product of prime numbers. So if we pick a number like 60, we could say that that is 3 times 20. 3 is prime, so we can't break that into a useful factor pair. 20, that could become 2 times 10. And these 2 are now prime. 10 can still split, that can become 2 times 5. So 3 times 2 times 2 times 5. Now any number can be written as a multiplication of prime numbers. And this is a lovely exercise in year 6, and you find that you always get the same answer, it's just that the numbers might be in a different order. The problem comes when you start to introduce 1. If you introduce 1 as being an option, then this goes on forever because you can multiply 1 in as many times as you like. So as numbers multiply together, the prime numbers build any number. But 1 doesn't help to build numbers because when you multiply by 1, your number doesn't change and you don't get anywhere. So there's some deeper sense in why 1 is not a prime number. As I've said before, prime numbers, factors, factor pairs, factor bugs are wonderful topics to explore as regular practice between the ages of 9 and 11, as children are looking to consolidate their understanding of their tables and the foundational ideas of multiplication and division. There's one extra exercise I would add in, and that is finding common factors. So if you consider, say, 15 and 45, quick warm-up, can you find factors in common or common factors for these numbers? And the child might say they've both got a factor of 1, or they've both got a factor of 5, or they've both got a factor of 3, or they've both got a factor of 15. All those things are true. And we're just getting them used to that language of common factors, which is really important in maths. It's important when you're simplifying fractions, and it comes up again and again in the future. And it's really effective if you can build children's confidence with that idea and with the vocabulary of common factors before they come across it in other places. So your takeaways from this video are to spend lots of time exploring prime and composite numbers and factor pairs by building rectangles. Then link the rectangles to factor bugs and do plenty of consolidation and practice of this topic for a long time until your child really knows the foundations of multiplication and division fluently and inside out and can do this. At some stage you should do a sieve of Eratosthenes, which is the number square, where you cross out the different times tables to leave the primes at the end of the exercise. 1 is not prime, both by definition, that it doesn't have 2 factors, but also because it's not a building block of other numbers when you multiply by 1, as prime numbers are. I hope you found this video useful. If you have any questions, please leave them in the comments here, or come and talk to me Sunday mornings at 9 AM British time and ask me questions live. If you haven't subscribed to the channel yet, please subscribe now so you can find it again, and please do share this channel and these videos with your friends who you think might find them useful. Thanks for watching. Hope to see you again soon for the next video, which is all about triangular, square and cube numbers. Bye for now.